Ever thought about how the internet works? Or are you too busy watching cat videos? It's a question that often stirs up intrigue. Yet many of us are so engrossed in our digital lives that we fail to appreciate the complex system that powers our online experiences. Just like a magic trick, we click a link and instantly, a web page appears. We send an email, and it crosses oceans and continents in a split second. But contrary to the seeming magic, there's a vast and intricate infrastructure tirelessly working round the clock. The internet, in its essence, is a global network of computers, all interlinked and communicating with each other. It's like a giant party where everyone's invited. Picture a gargantuan web of connections stretching across continents, under oceans, even reaching out into space. Every device connected to this web, be it the smartphone in your hand, the laptop on your desk, or the servers in data center, is part of this grand party. Now think about this. When you stream a movie, you're pulling data from a server thousands of miles away, all in real time. When you send a tweet, it's like whispering a secret that gets heard by instantaneously. The internet is the ultimate chatterbox, facilitating real-time communication and data transfer worldwide. But it's more than that. It's a genie that has revolutionized our lives and reshaped our society. From binge-watching our favorite shows, shopping at the click of a button, to spreading ideas and information, the internet is everywhere. It's the dynamo of our digital age, driving innovation and fostering global connection. It's changed industries, toppled governments, and even sparked new forms of art and entertainment. But despite its omnipresence, the mechanics of the internet remain a mystery to many. We tend to overlook the intricate ballet of technological elements that make it all possible. So let's pull back the curtains and explore the magic behind the scenes. Let's delve into the heart of the internet and uncover the secret sauce that powers this global party. So, what's the secret sauce that makes this global party possible? Stay tuned as we spill the beans on the internet's magic. At the heart of the internet, there is a complex infrastructure. Picture the internet as a sprawling city. The buildings in this city are servers where websites live. These servers are connected by a series of roads, which we call the internet's backbone. Much like in a city where you have major highways and smaller streets, the internet also has its large, high-speed networks and smaller, slower ones. These high-speed networks often span across continents and are operated by major telecommunication companies. We refer to them as the internet's backbone. Now imagine you're in your house and you want to visit a friend across town. You would need to use the roads to get there. Similarly, when you want to visit a website, your computer sends a request through a series of roads or networks. This is where internet service providers or ISPs come in. They act as the on-ramp to the internet highway, connecting your home to the wider network. But how does your computer know which way to go? That's where routers come into play. Routers are like the traffic directors of the internet. They analyze the destination of your data and decide the best route for it to take. This is a constant process, with routers continually communicating with each other to determine the most efficient pathways. All these elements, the servers, the backbone, the ISPs, and the routers, work together to form the infrastructure of the internet. But this infrastructure is not rigid. It's constantly changing, growing, and adapting to the ever-increasing amount of data flowing through it. So the next time you click a link or stream a video, remember the intricate cityscape of the internet that makes it all possible. This vast, interconnected web of networks, constantly buzzing with activity, is truly a marvel of modern technology. Now let's delve deeper into how data travels on these roads. Data doesn't travel whole, but in small pieces called packets. Now let's delve deeper into this fascinating process. Imagine you're sending a letter, but instead of a single envelope, you divide your message into several smaller notes, each in its own envelope. That's essentially how data transmission works over the internet. When you send information, say an email or a photo, from your device to another, the data isn't transmitted in its entirety all at once. Instead, it's broken down into these smaller chunks or packets. Each packet can be as small as a single byte or as large as 1,500 bytes. But these packets aren't just the raw data. They also contain essential information such as the sender's address, the receiver's address, the sequence number, and more. This metadata helps in the reassembly and error checking process at the receiving end. Think of it as the return address, destination address, and tracking number on your parcel. Now, these packets don't all take the same route from the sender to the receiver. They each travel independently, taking the most efficient route available at that moment. This is one of the reasons why the internet is so robust. Even if a particular path is blocked or slow, packets can be rerouted through a different path, ensuring the data reaches its destination. Once all the packets reach their destination, they are reassembled to form the original data. This reassembly process is based on the sequence numbers attached to each packet. It's like putting together a puzzle where each piece has a number on the back to help you place it in the correct position. This method of data transmission is highly efficient and resilient. It allows for large amounts of data to be sent over the internet quickly and accurately. It's like a well-oiled postal system, delivering millions of letters to the right addresses at the right time every single day. But how do these packets find their way around the vast internet? Well, that's a story for our next scene. Stay tuned. To navigate the internet, data packets rely on something called protocols. Now let's think of these protocols as a digital compass guiding our data packets through the vast expanse of the internet. The most notable of these are the Transmission Control Protocol, or TCP, and the Internet Protocol, or IP, collectively known as TCP/IP. TCP/IP is like the GPS of the internet. It's a set of guidelines that govern how data should travel from one device to another. IP, the Internet Protocol, is responsible for addressing and routing each data packet. It ensures that the packet knows where it's going and how to get there. Imagine you're mailing a letter. You'll need to write the recipient's address on the envelope, right? In the same vein, every device connected to the internet has a unique IP address. This address is like the recipient's name on the envelope. It's where the data packet is destined to go. But how does the data packet know where to go? That's where TCP comes in. The Transmission Control Protocol acts as a traffic controller, deciding how to break down data into packets, where each packet should go, and in what order they should arrive. TCP also ensures that each packet takes the most efficient route possible, even if that means packets from the same data file take different paths. It's like if you and a friend are driving to the same destination, but decide to take different routes to avoid traffic. You'll both still end up at the same place, just not necessarily at the same time. Finally, when all packets reach their destination, TCP reassembles them in the correct order, ensuring the recipient receives the complete file as intended. So, TCP/IP works together to ensure that every data packet knows where to go, how to get there, and arrives in the correct order. But you might be wondering, what happens if a packet gets lost? The internet has a built-in solution for lost packets. As we journey through the vast interconnected web that is the internet, we might sometimes lose our way. But don't worry, the internet has us covered. Just like a determined postman braving the elements, the internet has its own way of ensuring that all data packets reach their intended destinations. The first line of defense is error checking. When a data packet is sent from one place to another, it goes through a process called error detection. This is where the Transmission Control Protocol, or TCP, comes into play. TCP adds a checksum to each packet, which is sort of like a digital fingerprint. This checksum is a mathematical sum of all the bits in the packet. The receiving end recalculates the checksum and compares it to the one sent. If they match, all's well. If not, it's a sign that the packet was corrupted during transmission. But what happens when a packet goes missing entirely? That's where retransmission steps in. TCP isn't just responsible for error checking. It's also the internet's lost and found department. When you send a packet of data, TCP starts a timer. If the receiver doesn't acknowledge the packet before the timer runs out, TCP assumes that the packet has been lost and promptly sends it again. TCP also keeps track of the sequence of packets. So if a packet arrives out of order, the receiver can put it back in its rightful place. If a packet is missing from the sequence, the receiver knows to ask for it again. It's a bit like piecing together a jigsaw puzzle. You wouldn't just throw away a piece because it arrived out of order, would you? Retransmission and error checking ensure that our data gets where it needs to go, intact and in order. They're the unsung heroes of the internet, quietly working behind the scenes to keep our digital world running smoothly. So, we've seen how the internet works, but what about its impact on society? Let's delve into that next, as we continue our exploration of the vast, intricate and fascinating world of the internet. The internet has revolutionized society in countless ways. It's like a boundless library, a worldwide stage, a bustling marketplace, and a global coffee shop, all rolled into one. The spread of information, a hallmark feature of the internet, has transformed the way we learn, communicate, and interact. With a few clicks, we can access a treasure trove of knowledge, from online encyclopedias to academic journals. We're no longer confined to physical libraries. The world's knowledge is at our fingertips. This democratization of information has opened up opportunities for self-education and lifelong learning, empowering individuals across the globe. Then, there's the phenomenon of online communities. Social media platforms, forums, and chat rooms have become virtual town squares where people gather to share ideas, discuss interests, and voice opinions. These digital spaces have brought together like-minded individuals who might never have crossed paths in the physical world, fostering a sense of belonging and camaraderie. The internet has also given rise to a dynamic digital economy. Traditional brick-and-mortar businesses have been complemented by e-commerce platforms, allowing consumers to shop from the comfort of their homes. Meanwhile, the gig economy has gained momentum, offering flexible work opportunities to millions. And let's not forget the emerging realm of non-fungible tokens, or NFTs, creating new avenues for artists and collectors. Yet the internet isn't without its challenges. From privacy concerns to digital divides, the internet poses several challenges. Let's delve into some of these issues that are associated with this vast network. One of the most pressing concerns revolves around privacy. With the rise of social media platforms and data-driven services, personal information is more accessible than ever before. Recent debates around apps like TikTok highlight the need for comprehensive data privacy regulations. The question of how to balance national security concerns with economic interests in the tech industry is a puzzle that policymakers grapple with. Next, the security of the internet. Cybercrime is a growing threat in the digital age, with hackers and malicious software posing significant risks to individuals and organizations alike. The ever-evolving nature of these threats requires constant vigilance and innovation in cybersecurity measures. Moreover, the internet is also a battlefield of information. The recent coup in Myanmar, for instance, underscores the role of the internet in shaping narratives and influencing public opinion. Misinformation and propaganda can spread rapidly, making it challenging to discern truth from falsehood. Another challenge is the digital divide. Despite the internet's widespread reach, access disparities persist. Many communities, particularly in developing regions, lack reliable internet access. This digital divide exacerbates social and economic inequalities, and efforts to bridge this gap are crucial. Lastly, the rise of NFTs and virtual assets presents new challenges. As we've seen with projects like Loot and Dope Wars, millions are invested in games that don't yet exist. This speculative nature of NFTs raises questions about their sustainability and the ethical implications of such investments. Despite these challenges, the internet continues to evolve. As we navigate these complexities, it's important to remember the potential of the internet to foster creativity, collaboration, and global connectivity. It's this potential that pushes us to strive for solutions, ensuring the internet remains a force for good in our increasingly digital world. The future of the internet is as exciting as it is uncertain. As we stand on the precipice of this digital frontier, we can glimpse a myriad of potential developments that may redefine our online experiences. One such development is the rise of advanced connectivity. We've already seen the internet transform from a luxury to a necessity, permeating every facet of our lives. But we are now moving towards an era of ubiquitous connectivity, where virtually every device, from our home appliances to our cars, will be internet-enabled. This blossoming Internet of Things, or IoT, promises to revolutionize our daily routines, making our lives more convenient, efficient, and interconnected than ever before. Another key development is the evolution of digital media. We've seen the internet grow from a platform for text-based information to a vibrant multimedia space. But the recent boom in non-fungible tokens, or NFTs, is pushing the boundaries of digital ownership and creativity. These unique digital assets are paving the way for novel forms of art, gaming, and even virtual realities. Imagine owning a unique piece of digital art or a rare item in a game that doesn't even exist yet. That's the power of NFTs. Of course, these developments are not without their challenges. The rise of IoT brings with it concerns about privacy and security, as more devices mean more potential entry points for cyber threats. The NFT boom too has been criticized for its environmental impact and potential to enable speculative bubbles. But amidst these challenges, the internet continues to evolve and adapt, driven by a relentless pursuit of innovation. It's a testament to the resilience and ingenuity of the human spirit, always pushing the boundaries of what's possible in this digital age. The internet, a marvel of technology, continues to shape our world in ways we can only begin to imagine. In this journey through the internet, we've seen its workings, impact, and potential future. We've delved into the magic of the internet, understanding how it's much more than just a global network of computers. It's a complex system that uses intricate infrastructure and technologies to function seamlessly. We've explored the internet's infrastructure and how data travels through ISPs, routers, and backbones. We've learned about the transmission of data in packets and how our digital messages are broken down, sent across the globe, and reassembled perfectly at their destination. We've also uncovered the role of internet protocols, the rules that govern data transmission. These protocols, like the TCP/IP stack, ensure that our data reaches the correct address without getting lost in the vast expanse of the internet. We've seen how the internet checks for errors and retransmits data, ensuring the integrity of our information. It's a relentless process, working tirelessly behind the scenes every time we send or receive data. Beyond its technical aspects, we've investigated the societal impacts of the internet. We've discussed how it's reshaped our world, from how we communicate and work to how we learn and play. We've confronted the challenges of the internet, like the need for comprehensive data privacy regulations and the complexities of balancing national security with economic interests in the tech industry. We've also acknowledged the internet's role in global events, such as political upheavals and the rise of digital economies. Finally, we've looked to the future, considering the potential of experimental projects like loot and dope wars and how they might redefine our online experiences. In this vast digital universe, every click, every message, every video watched is a testament to the remarkable technology that underpins our connected world. So the next time you click on a link or send a message, remember the incredible technology that makes it all possible. If you like this video, please go ahead and subscribe our channel to receive all the updates and the latest trending news. Your comments to improve our new channel will be highly appreciated. Thank you for watching.